Hey guys, Mr. Bowman here. Today's learning objective is in yellow and we are learning to identify the angle properties in relation to exterior angles of triangles and other polygons. So I've underlined exterior angles because that's the key concept that we're looking at today. So if you look at a regular triangle, so that's our triangle, if you extend any of the sides, that reveals an external angle. We could extend this one here to get there. So there's a few external angles in every shape. And the key thing to note, it's not the vertically opposite ones. So we mustn't pick those up by accident. So it's not those ones directly opposite from the angles of the triangle. We all know they would be vertically opposite angles. So hopefully that makes sense. So let's get rid of those and I'll leave just a basic example. So that's an example of an exterior angle. And in the video, we're going to focus on a few types. We're going to start off with irregular polygons. So depending on the shape, depends on the rule how you use. We're then going to change pen colors. We're going to move on to regular polygons. So they're unique, so they've got a different rule that could apply to them. And then finally, we're actually going to finish up just by summing up the triangles, just because there's a few unique things with triangles, which means we can actually apply quite a few of the rules that we're learning today. So irregular polygons, just a reminder, these are polygons where the sides aren't equal. So they've got unequal sides. And I'm just going to make up an example here. So I've drawn a bit of a weird kite, and I'm extending this angle here, and I'm trying to calculate angle X. So the only bit of information I need to find this is this angle here. And I can find this angle by finding all the internal angles of the polygon to reveal this angle. And let's just say that there is 100 degrees. If that's 100 degrees, well, we know that 100 plus x, they sit on a straight line, which means 100 plus x, or that must be equal to 180 degrees, which tells us that x must be equal to 80 degrees, and that's because angles on a straight line sum to 180 degrees. So irregular polygons, they're relatively straightforward to figure out the external angles. So we're going to now move on to regular polygons. Oh, and it's a bit different for regular polygons. We can actually apply the same rule. So let's look at maybe a pentagon. Oh, actually, no, let's change that to a hexagon. So we've got 6 equal sides. Apologies, my diagram isn't quite to scale. And let's say we're trying to find out this angle here. We're going to call the angle Y. How would we go about finding that? Well, there's a few different ways. And one way is we can use the straight line rule. So if we can figure out the angle that is also on the straight line, then we can apply the same rule. And we can do that by our rule from our regular polygons. So it's got 6 sides. So it's going to be 6 minus 2 times 180 is equal to 720 degrees. There are 6 angles in this shape. So 720 degrees divided by 6 equals 120 degrees. So that there reveals this angle, and we know that 120 plus y must equal to 180 degrees, which means y is equal to 60 degrees. And that there we've used the straight line rule to figure that out. So that's the first method. So we'll put a 1 around that. Alternatively, we can actually find that out another way. And what I'm going to do is I'm actually going to get rid of this 120 because we don't need that 120 in theory to find this out. So there's a new rule for regular polygons. An exterior or exterior angles, spelled that wrong, I'm just going to fix that. Exterior angles is equal to 360 divided by the number of sides of that regular polygon. So let's test to see if we can get our same answer as before. So our hexagon had 6 sides. That's going to be 360 divided by 6. Divided by 6. That there comes to 60 degrees. So we actually do get the same answer, which is really good. So we can use either of these approaches. But just a friendly reminder, this bottom one here, this is unique to regular polygons only. It won't work for anything else. And in terms of our reasoning, well, we do need to state something. So exterior angles are equal to 360 divided by n. So that's how I'd explain that one there. Okay, finally, let's switch to the pink pen. Let's have a go at triangles. And triangles is a bit of uniqueness to triangles because we can, in theory, apply any of these rules. So I'm actually going to focus on an equilateral triangle, just because that's got the most interesting features. So we're trying to find out, we'll call that angle Z this time. We're trying to find angle Z, and for an equilateral triangle, there's actually 3 methods you can use. One of them won't work for regular triangles or other triangles, but let's get into it. So the first one is, well, we know equilateral triangles, they've got an internal angle of 60 degrees. So we can use that straight line rule again. So we know that Z plus 60, well, that should be equal to 180, which means Z is equal to 160 divided by 180 minus 60, which means Z will be equal to 120 degrees. And I'm not going to write it out in full, but I'm just going to note I've used my straight line reasoning. But just a friendly reminder, in your books, make sure you're writing it out full every single time. So that was the first method we could use. The second method we can use, we could have used the exterior angle formula from before. So this is a regular polygon as well, so it means we can use that. And I'm just going to note it only applies to equilateral triangles because they are regular polygons, not other triangles. And so our triangle has 3 sides, so 360 divided by n is the formula. 360 divided by 3, well, that comes to 120 degrees. And that's the exact same before. And just to justify that, friendly reminder, you'd use your 360 divided by n formula to do that. And the final one, and I'm just going to note this applies to all triangles, is using the opposite sides. So I'm going to draw a non-equilateral triangle this time. And what I'm just trying to suggest here is x plus y, the 2 opposite angles. So this is our exterior angle, and we're going to look for the opposite ones. X plus y will actually always be equal to z. So let's get that down. So x plus y is always equal to z. So let's say x was 80 degrees, and let's say y was 70 degrees. How much would z be? Well, we can plug both those values in. So 80 plus 70 equals z. Z must be equal to 150 degrees. And just like for our other reasoning, just going to delete that line to give us a bit more room. We do need to always state a reason. And then, so an exterior angle of a triangle sums to the opposite 2 interior angles. And that's good. So even though that's a long sentence, that's something we can copy down and use every time we apply this rule. So that applies to all triangles, but just to note, the one above only applied to equilateral triangles because that was a regular polygon. And we found out that, well, we can apply that straight line rule to actually any type of polygon to find the external angles. So guys, hopefully you found this video useful. We went over how to find the exterior angles of given shapes. We found out for regular polygons, well, you can only use the straight line rule to do that. For regular polygons, you can use the straight line rule in conjunction with other rules we've previously learned. You can also use a unique rule with regular polygons, 360 degrees divided by n. And for triangles, you can always use the straight line rule again. If it's a regular polygon, you can use the regular polygon 360 degrees divided by n rule. And there's a rule unique to triangles. The exterior angle is equal to the opposite two internal angles. Right, hopefully you found the video useful. Now let's get into heaps of practice.